Hello everyone, this is Dr. Prashanth and welcome back to Biostatistics lecture series. In this video, we will discuss about the probability distributions. To start with the introduction, a probability distribution is a device through which the relation between the values of a random variable and the probabilities of their occurrence may be summarized. It may be expressed in the form of a table, graph, or a formula. It provides the clinician and researcher with a powerful tool for summarizing and describing a set of data and for reaching conclusions about a population of data based on a sample of data drawn from the population. So basically there are two types of probability distributions: probability distribution of discrete variables and for continuous variables. For discrete variables, we use binomial and Poisson distribution, whereas for continuous variables, we use normal distribution. Let's look into each of these distributions in detail. To start with the discrete variables, the probability distribution of a discrete random variable is a table, graph, formula, or other device. Use it to specify all possible values of a discrete random variable along with their respective probabilities. So let's understand the concept of discrete random variable. A discrete random variable is characterized by gaps or interruptions in the values that it can assume. These gaps or interruptions indicate the absence of values between particular values that the variable can assume, which we have discussed already in the initial lectures. So let's see some simple examples. Number of daily admissions into a general hospital. So it can be 0, 1, 3, 5. It can't be 1.2, right? Similarly, number of missing tooth. It can be 1, 2, 3 and so on. So this is the first example. Prevalence of drug usage in pregnant women. So there are two columns. The first column is the number of drugs taken by the pregnant women and the frequency are the number of women who took the particular number of drugs. So let's see how we calculate the probability in this case. The first two columns are clear. So in the third column, we calculate the probability by dividing the specific frequency by total frequency. For example, if you want to see the probability for the number of drugs taken are 0. So we use 1425 divided by the total frequencies in this case is 4185. So we get 0.3405. That is the probability. Similarly, we calculate for the all categories. So let's see with some numerical examples using the previous data. In the first example, if you want to know the probability that a randomly selected woman will be one who used 3 drugs. So let's go back and see the probability of 3 drugs. It's 0.0832, right? So similarly, what is the probability that a randomly selected woman used either 1 or 2 drugs? So in this case, they are asking either 1 or 2. So go back to the properties of probability distribution. Properties of probability. We have already discussed some rules in the concept of probability, right? So in this case, we apply addition rule. So if you want to know either 1 or 2 drugs, we add both the probabilities, probability of 1 drug and probability of 2 drugs. So go back to the table, see the probability of 1 and 2, it's 0.32 and 0.18. So add them and you will get the probability of 0.5123. So now coming to cumulative distribution, so it is very easy. The first 3 columns are clear, right? The number of drugs, frequency, and we know how to calculate the probability. Cumulative distribution is nothing but we add the individual probabilities till the final category, right? So it's very simple. For example, the first probability is 0.3405. So you add that to 0.3228 so that you get 0.6638. Similarly, we add 0.1895 to 0.6633 and so on. So now coming to cumulative distributions, it is similar to the previous concept, but in this case, we add the individual probability to the next probability to get the cumulative probability. Let's understand with a simple example. For example, the starting probability for the woman who used 0 drugs, no drugs, is 0.3405, right? So we add 0.3405 to the next probability, that is 0.3228 to get 0.6633. Similarly, we add 0.1895 to 0.6633 to get the cumulative probability of that particular category. So let's see the uses of this. For example, if you want to know the probability that a woman randomly selected will be on who used 5 or more drugs. So they are asking us to know the probability of women who used more than or equal to 5 drugs. So now go back to the concept of probability. We already know that the total probability is 1, right? So in order to get this, we subtract the probability of women less than or equal to 4 drugs from the total probability. So the total probability is 1 minus probability of x less than or equal to 4. So that you get 0.0267. So this is the probability of women who used 5 or more drugs. Similarly, if you want to see the women who used between 3 and 5. So what we do, we go to the cumulative probability of women who used 5 or less than 5, which is around 0.9872, right? So we subtract that from probability of women who used less than or equal to 2, so that we get the value between 3 and 5 drugs. So less than or equal to 2, the probability is 0.8528. So you subtract 0.8528 from 0.9872. So you get the probability 0.1344. Now, to begin with the binomial distribution, it is one of the most widely encountered probability distribution in applied statistics. It is derived from a process known as Bernoulli trial. Let's understand the trial. When a random process or experiment called a trial can result in only one of the two mutually exclusive outcomes, such as dead or alive, sick or well, male or female, etc. The trial is called a Bernoulli trial. So in this, we come across with a new concept called combination. So what is a combination? If a set consists of n objects and we wish to form a subset of x objects from these n objects, without regard to the order of the objects in the subset, the result is called a combination. So the formula in this case is n factorial divided by n minus r factorial into r factorial. So let's understand the concept of combination with an example. Given sample of 5 birth records, they are asking us to find the probability that 3 of them will be for male births. So in this case, what is the sample size? N is 5, and what will be the R? What is the condition in this case? 3 of them will be for male births, so R will be 3. So using the formula, n factorial will be 5 factorial, right? And divided by n minus r, that is 5 minus 3 factorial into 3 factorial. So by doing the calculation, the answer is 10. And now coming to the formula of binomial distribution, it is a universal formula. Let's understand or break down the formula first. Probability of x equal to ncx multiplied by p power x into 1 minus p into n minus x, or probability of x equal to ncx multiplied by p power x into q power n minus x. So let's understand this term so that you will get a better understanding. P is nothing but the probability of success of an event. Q is the probability of failure. So the alternate word for it is 1 minus P. We can use Q if they have given you directly Q, or you can get Q by subtracting P from 1. The total probability is 1, and if you know the success, subtract the success from the total probability, so you get the probability of failure. Similarly, N is the total number of events and X is the total number of successful events. So let's understand this with a numerical example. 30% of a certain population are immune to some disease. If a random sample of size 10 is selected from this population, what is the probability that it will contain exactly 4 immune persons? So let's break down the question. So let's see what they have given us. Probability of an immune person, that is the success. P is equal to 30 by 100, that is 0.3. So now you can calculate the probability of not an immune person, right? That is Q. How we calculate it? We subtract the P from the total probability, that is 1. 1 minus P equal to 1 minus 0.3, that is 0.7. So let's see the total sample size. N is given as 10, and what is the condition or the X here? Total number of successful events. It is given as 4, exactly 4 immune persons. So by using the formula, that is ncx multiplied by p power x into q power n minus x. So substitute the values in the formula. So you get the answer as the probability that it will contain exactly 4 immune persons is 0.2001. And now coming to the next distribution of a discrete variable, that is called Poisson distribution. If x is the number of occurrences of some random event in an interval of time or space, the probability that x will occur is given by a formula lambda power x divided by x factorial into e power minus lambda. Let's understand the terms. Lambda is nothing but the average number of occurrences of a random event in the interval. So here one factor that comes into play is the time. And what is E? E is nothing but the constant and its value is 2.7183. So let's understand this with a numerical example. So before that, let's see what exactly the Poisson process and what are the characteristics of a Poisson process. The occurrences of events are independent in Poisson process. An infinite number of occurrences of the event must be possible in the given interval. The probability of the single occurrence of the event in a given time interval is proportional to the length of the interval. In any infinitesimally small proportion of the interval, the probability of more than one occurrence of the event is negligible. And the most important thing is the mean and the variance are equal in Poisson distribution. So as already said, we'll look into some numerical examples for Poisson distribution. In the first example, let's see what they have given us. The monthly distribution of adolescent suicides between 1977 and 1987 closely followed a Poisson distribution. So there is a time period interval and they told us it followed a Poisson distribution. And lambda is given as 2.75. And they are asking us to calculate the probability that a randomly selected month will be one in which 3 adolescent suicides occurred. So just break down the question and write down the values of each. We know the lambda, we know the value of E, substitute the values. So you get the probability as 0.221584. Similarly, in the next example, in the previous example of the future adolescent suicides in the population, follow a Poisson distribution. What is the probability that a randomly selected future month will be one in which either 3 or 4 suicides will occur? So let's understand the question. They're asking either 3 or 4 suicides will occur. So it is a kind of yes or no type of question, right? So to calculate this, we need to add the both probabilities, that is kind of addition rule which we have done in the last question. So the probability of 3 suicides plus the probability of 4. So what is the probability of 3? We have already calculated in the first example. It is 0.221584 plus the probability of 4. Just substitute the values e power minus 2.75, which is lambda, multiplied by lambda power 4 divided by 4 factorial. So the answer is 0.373922. And now coming to continuous probability distributions, let's start with the meaning of continuous variable. A continuous variable does not possess the gaps or interruptions, whereas a discrete variable has gaps in between. It can assume any value within a specified relevant interval of values assumed by the variable. Simple example, height, weight. And now coming to the definition of continuous probability distribution. A non-negative function f of x is called a probability distribution of the continuous random variable x if the total area bounded by its curve and the x-axis is equal to 1. And if the sub-area under the curve bounded by the curve, the x-axis, and the perpendiculars erected at any 2 points a and b gives the probability that x is between the points a and b. So it's very difficult to understand with the definition. So in the next slide, I will explain that with an example. So let's see how a normal distribution look. It is also known as Gaussian distribution. It is the most important distribution in statistics. It is symmetric bell-shaped curve with more values concentrated in the middle than in the tails. 2 parameters describe a normal distribution and they are the mean and the standard deviation. Let's see the characteristics of the normal distribution. So now the definition which I have told in the previous slide will come in this concept. It is symmetrical about its mean in the center, right? And the mean, median and the mode are equal in normal distribution. And the total area under the curve above the x-axis is 1 square unit. So you see the diagram which I have given in the 4th point. Total area under the curve above the x-axis is always 1. And in the 4th point, if we extend perpendiculars a distance of 1 standard deviation from the mean in both directions, that is left and right, the area enclosed by these perpendiculars, 2 vertical lines, the x-axis and the curve will be approximately 68% of the total area. Similarly, if you extend 2 standard deviations, and it will be approximately 95% of the total area, and in case of 3 standard deviations, it will be approximately 99.7%. So you can understand this by seeing the diagram which I have given below. 95, 99 and 68. 68 in case of 1 standard deviation, 95 in case of 2 standard deviations, 99.7 in case of 3 standard deviations. And coming to the last point or the last characteristic, the normal distribution is completely determined by the parameters mean and standard deviation. And now coming to standard normal distribution, a standard normal distribution or unit normal distribution has a mean of 0 and the standard deviation of 1. And it is also called as Z distribution. Normal distribution is standardized by converting its values into Z-scores. What does it mean? You can convert a normal distribution into standardized normal distribution by converting their values in the form of Z-scores. So how to calculate it? So we got a formula for that. Z equal to x minus mu divided by sigma, where x is the observed value. So z-score tells us how many standard deviations from the mean each value lies. Okay. For example, if z-score is 1.23 after calculating, it means a particular value or observation is 1.23 standard deviations from the mean of your distribution. After calculating z-score, we can calculate the probability of this using the z-table. For example, if the heights of a certain population of individuals are approximately normally distributed with a mean of 70 inches and a standard deviation of 3 inches. So they have given us mean and standard deviation, and they are asking us to find the probability that a person picked at a random from this group will be 65 inches tall. So let's start. In the first step, calculate the z value corresponding to an x of 65, right? Because they are asking us to find the group of people whose height is 65 inches tall, right? So substitute the values in the formula, z formula, x minus mu by sigma. What is x in this case? It is 65 minus, what is the mean? Given mean is 70, divided by what is the standard deviation? It's 3. So you get the z value as minus 1.67. In the next step, calculate the probability using z table. The probability of z equal to minus 1.67 is 0.0475. And in the second question, if they are asking you to find 74 inches tall, everything remains same, but in the place of x you put 74, right? So 74 minus mu, that is 70, divided by standard deviation is 3. So you got z as 1.33. So the probability of z value of 1.33 is equal to 0.9082. Similarly, if you want to find between 65 and 74, so in this case, we need to find the probability of x, which is between 64 and 74, right? So you already know the probability of 65 in the first question, that is 0.0475, right? And you know the probability of 74, which is around 0.9082. Now you need to subtract the probability of 65 from the probability of 74. That means 0.9082, which is the probability of 74 inches tall, minus 0.0475, which is the probability of 65 inches, right? So the answer is 0.8607. I hope this is clear. Thank you.